Hi there. In this Blender 2.8 tutorial, I'm going to use the Eevee renderer to create a scene something like this. So we've got a number of things going on here. We've clearly got some volumetrics here, some volumetrics that's not homogeneous, there's holes in it, so to speak. We've got what you might call asteroids or rocks floating around. The camera's got some relatively complex movement in some versions of the scene. Here you go, you can see the camera's whizzing around, sort of tracking, but it's actually not focused on just a single one of the objects. And then of course we've got these coloured objects flying around in a semi-random way. They're actually staying sort of focused in a particular area, but you can see they're not just simply flying around in circles, they're varying their movement a little bit. So I'm going to show you how to do all of this and do it in Eevee, so it's almost a real-time render. So to begin with, let's just create the objects that are going to fly around. I'll make less than I made in the other scene because obviously we just want to show you the techniques here rather than go into all the detail of the entire scene. But before we go any further, let's change the render mode. So I'm in Blender 2.8. It's 2.8 beta, so there are a few little things that are yet to be tidied up. But if we come up to here, the little sort of computer symbol, click in here and select Eevee. Nothing obviously changes to begin with. And we're going to need to turn on some of the elements in here later on. But to begin with, we'll just go with what we've got. I'm going to click up here as well and just click that button there, which will mean when we've got a coloured object in the scene, we'll be able to see what colour it is. Then come over here, which is selecting the 3D cursor, and we'll click here so we know where our objects are going to appear when we create them. I'll go back to that. So Shift A to add an object, and we'll add a simple icosphere. Now to begin with, it may have too many subdivisions. I'm actually going to stay with these, but if you click this little arrow here, you get an option to change the number of subdivisions here to increase or decrease it as you see fit. I'm now going to come down to Materials, we'll say New, and we'll call this Yellow. I'm going to click right on the corner there and pull down. It's a little bit tricky with this version. I think they need to put those chevrons back. And you have to click in that little tiny area there and then left click and pull down. Then I'm going to come up here and change this window to the shader editor. So you can see by default it puts the principal to be SDF in there. Press N, that'll get rid of that right hand window. But I don't want to use that, so I'm just going to delete it. And then I'm going to add a shader which is an emission shader and just connect that to the surface. And I'm going to change the colour to yellow and I'm going to set the strength to something like 3. So if we go to our rendered scene now, obviously nothing much changes. One of the things we do want to change is the colour of our background. So if we come up to here, click Use Nodes and just go into Colour and change it to black. If you don't want to see the grid, you can just click this and obviously the grid disappears. But you can see our object is now a glowing sphere. So if we come back to the little computer settings, we can now show that we're actually rendering, because I can put on Bloom, for example, and you can see we've got a glow around our object. I'm going to leave that off for now. And in a little while we'll use volumetric. We may not even need to use the bloom with the volumetric on there. But I'll come back to just the colour render because it's a little bit more responsive. But that'll do for the moment on the material. So I now need to give this object some movement. I'm going to make it a little smaller first, I think. So left click it, S for scale, and then Control A and apply rotation and scale. Doesn't matter too much for this exercise. I'm going to press I with the object selected, and I'm going to select location. And I'm going to widen this window up a little here. And I should have said that my pointer is at the first frame. I'm just going to stick with the default number of frames here, but in the render I did about 3000 frames. And you can certainly do these larger frame counts relatively easily with Eevee because it does render quite quickly. I was getting something like 5 or 6 seconds per frame, which for a fully rendered scene is pretty good. There are obviously limitations. So I'll come up to here now and I will select the graph editor. With my object selected, you can see we've got a point or a couple of points there. If I click this here, you can see we've got X, Y and Z location, and different lines were lighting up. And you can see the actual height of the line determines the position of the object. I'm going to press N now over that window. That brings up this right hand menu and select modifiers. So there are no modifiers at the moment. If I press play, nothing happens down here. So I'm going to add a modifier and it's going to be a built-in function. And you can see we get a sine wave straight away. If I back up a little bit and press play now, you can see our little object is just bouncing up and down. And that's because I had the Z axis selected when I added that modifier. So let's increase the amplitude, which will increase the amount that that object bounces up and down, but reduce the phase multiplier. So let's try 0.2 to start with. So you can see it's much slower now. And I ended up using quite small phase multipliers. So a phase multiplier is basically how fast this, in this case a sine wave, is being used. You can use other waveforms. So you can click in here and you can try cosine, which is pretty much a sine wave again, tangent, which is a lot weirder, or any of these others. But you'll tend to find they're not as good as a sine wave. But even though it's a sine wave, we're not going to have completely repetitive movement like that, as you'll see in a moment. So let's put this down to 0.025 now. So that's much slower, as you can see. And now I'm going to add, I'm just going to minimize that. I'm going to add another built-in function. Again, it's a sine wave. And I'm going to click additive. So you can see there's that little sine wave superimposed on the big one. I'm going to increase the amplitude quite a bit. And I'm going to reduce the phase multiplier to perhaps 0.01. Let's try that. If I zoom out, you can see what that's doing. Perhaps we'll go to a lot bigger than that. 0.1 we'll go with. So now you can see it's not a simple sine wave anymore. If I took off additive, it doesn't work that way at all. And we can play with the amplitude here and the phase offset. And of course, we can add another one. I'll add another built-in function. We'll select additive and we'll increase the amplitude a little and turn the phase modifier down to perhaps 0.15. So it's similar to the other one, but not exactly the same. What we're doing here is something called Fourier transforms. Essentially, we're creating a particular waveform, or whatever waveform we end up creating, by adding together lots of sine waves. The theory is that you can actually create, and in fact the practice is that you can actually create any waveform you like. You can create the sound of my voice, for example, just by adding lots and lots of sine waves together. A sine wave is the root of them all, as it were. So it's creating lots of what are actually harmonics and things like that. And it's all constructed of the phase offset, the phase multiplier or the frequency, and the amplitude. And each of those things will change that waveform. So we've only been doing this on one axis at the moment. So let's select another axis. Let's go for the x-axis. We'll add a modifier and it'll be a built-in function. We'll increase the amplitude, and already you can see it's getting a little weirder. We'll turn the phase multiplier down. You can go negative, of course. So you can see we're getting sort of little spirals there because it's oscillating. You can just about see, you may just be able to see as sort of ghosted in the background, the Z waveform superimposed on our red X waveform. If I select Z, you can see how the two vary. So now I'll minimize that one, add another built-in function, increase the amplitude of that one, select additive, and again reduce the phase multiplier. And you can now start to see we're getting what appears to be a much more random motion. Now what you will tend to find is initially there's still a periodicity that aligns. They still sort of do their thing aligned with each other, which may be what you want or may not be. But you can use this phase offset to change where they're coming in and out. You can also change their base position, so the central position, by playing with this offset here. You need to move the object around a little bit. But one of the good things about this is it's pseudo-random movement. It's not really random, of course, it's cyclic. But it is centered around a particular position. So that's quite useful if you're trying to create a movie of it, as it were. You know where it's going to stop, where the top of the movement is going to be, you know where the bottom is, and the far left and far right. And then finally we can do the same, and you don't just have to have two, you can have 3 or 4, however many you want, to make as complex a movement as you want. So let's just quickly add a modifier here, built-in function, turn the amplitude up, set the phase modifier to perhaps 0.12. It's good to have them at different frequencies. Give it a random phase offset, then add another one. Turn that one up a little bit and set it to additive, perhaps somewhere around there with a phase offset. So now we can see we've got our object down here, and in all axes it's got this semi-random movement. Roughly speaking, it appears cyclic. It's sort of like a firefly or beetle or something flying around a bright light. It's just random, but it's only pseudo-random. So that's a good start. The next thing I'm going to do is I'm just going to put my 3D cursor there, and then I'm going to add a lamp. We'll make it a point lamp. There's only certain lamps supported in EV at the moment. And we'll make it coincident with our object. I'm going to go to wireframe mode. I just pressed Z there just to make it a little easier to see what I'm doing. And I'm just looking from above so that I can get it lined up on the y-axis and all the axes. So that's fine. I'm now going to hold Shift down and select my object, Control P, and say Object, Set Parent Object, Keep Transform. So now when I move around, the lamp moves around with the object. So by default it's been putting these into a collection called Collection. We'll call that Main now. So this is a bit like layers. I'm going to select the lamp called Point, and I'm just going to call it Yellow Light 1, and the icosphere Yellow Object 1. So I'm just going to select my light and come down to Lamp Properties, and we'll change the radius so that it's larger than the object. I did this just to make sure that the object didn't shadow the light. In Cycles you can turn an object's ability to cast shadows off, but I don't think it's quite as straightforward in EV. Interestingly, the power appears to be in watts, so I'm going to turn that up to 45 watts, but I'm going to leave shadows on. And of course we'll make it a nice yellow light. So let's quickly go to EV and see what that shows us at the moment. If you click here, you can turn off the overlays, so you just see what the camera would actually see. And obviously we can turn on bloom again, and there's our object. So let's stop that. Let's go back to material view, turn our overlay back on, go to the beginning of the time frame, press A to select everything, double A if you want to unselect first. Make sure I'm just making sure my camera isn't selected, but it's turned off at the moment. It's in collection 2. Shift D to copy it and just put the copy over here. Don't move the timeline yet because this will jump back to the same position as the other one, and then it won't be so easy to select. So having moved the object away, we first of all need to delete the modifiers. So first of all, delete the modifiers. And now move your yellow object to somewhere random elsewhere. So I'll move it to here. Obviously the light's still following it. I'm going to call this Blue Object 1. We'll go to Material, click the little 2 here and call this Blue, and just change the colour of the lamp to a light blue colour. Then we'll go to the Yellow Light 001, double click that and just say Blue Light 1. Select our object again, so that's the blue object. Press I and say Location. And you can see we press play, nothing happens. If you try to set a new location with the modifiers still on there, I found it doesn't seem to work. You need to delete the modifiers first. So let's add a built-in function. We'll give it larger amplitude, a phase multiplier of 0.05 in this case, random phase offset, and then we'll give it another built-in function, another larger amplitude, random phase multiplier that's a bit smaller than that, and additive. And I'll just do 2 for this one, and I'll just do something on the X as well. Built-in function, larger amplitude, smaller phase offset, and then again. Okay, if we now look at them, they're moving in a similar way. I haven't put a Y movement on the blue one, but they're not identical. So that's our objects and the movement done. Next, let's make our sort of asteroids or whatever they are. We'll change this back to a shader editor. We'll come over to one side, just move our 3D cursor there, and we'll add a mesh icosphere, and we'll give it 3 subdivisions to start with. I'll just zoom in on that. So the first thing I'm going to do is go to modifiers, which is this little spanner shape here, or wrench I think in some countries. I'm going to add subdivision surface. And eventually I'm going to turn this up a little higher, but we'll leave it at 2 for the moment. And then I'm going to add a displace modifier. I'm going to say new here, and then click this little control here. And this takes me to another place where I can select textures. And I used Musgrave, which is this one. I changed that to original Perlin. Again, you can use whatever shape you want. This just seemed to do what I wanted, and change that to ridged multifractal. Then go back to my modifier and set the strength to 0.1. Also going to change the object. If I right click on the object, I can actually say shade smooth, and then I'm going to add another modifier, another displace modifier, say new here, and I'll call this one noise. I'm going to set the strength to 0.1 again, leave the mid-level where it is, and then come over here. It's defaulted to Musgrave again, but this time I want clouds, which are essentially noise. I'm going to select Voronoi F2. Grayscale is fine for my purposes. I used a size of 0.05. That will vary a lot depending on the scale of your scene. And then these I left at default. And the only thing I changed here was I turned brightness down a little bit. And you can see it just changes the mid-level layer. It gives me some black basically. And if you want to, you can add some contrast. but we're struggling a little bit because we haven't got enough detail in our model. So if we go back to modifiers, go back to our subdivisions and now turn that up one, and you can see we've now got a little bit more detail in there. So there are various tricks on how you can now create some variations on this, but I didn't bother too much with anything fancy. You can use displace modifiers like this to create various versions of this, but I've shown how to do that in other tutorials. So I'm just going to select a single point here, press O to turn on proportional editing, then press G and just pull that over a little bit and come out of edit, and you can see we've got some changes. Select a couple of points there. Remember, it's left click to select by default in Blender 2.8. Scale, and I'll make that a little smaller, so we'll just push that in there. So before I go any further, I'm now going to just create the material. So we'll come down here, pull that down a little, and we'll just say new for material. We'll call this asteroid, and by default it's put the principled shader on there for us. So I'm just going to select the base color as a sort of dark brownish color. Roughness, I've left it about the mid-level. You can have it even higher if you want. And everything else I left pretty much as it was. I didn't go into too much detail on that material because you only really see these from a distance. You're not getting a close-up view. So that's a nice, basically very dark material for our asteroid. And now we can create some variations of it. So I'm just going to create 3 of these. For my scene, I think I did about 7 or 8. Then go into edit mode, make each one different, just so they're not all identical, obviously. And then holding the shift button down, select them all and say M to move these to a new collection, and we'll call that asteroids. OK that, and you can see here it is. And I'm just going to turn off the visibility to the render of those so that they don't show up when we actually do a render. In fact, I'll turn them off completely so they're not even showing up in here. So the next thing that we need to do is add our volumetrics. So that's pretty straightforward. Just put my 3D cursor there and then add a cube. Make sure the cube's somewhere useful. Scale it up to enclose pretty much everything. Obviously, exactly how big you need it depends on your scene. Let's press play while we're in wireframe mode and see if that encloses the movement of our objects. It seems to be doing that, so we can probably even make it a little smaller. Best not to have it any bigger than you need it to be. In my scene I had my camera spinning around as well, so I had to allow for that. So we'll call this object mist. We'll give it a new material and we'll call that volumetrics, and we'll remove the principled BSDF shader. Now I tried using the principled volume shader. I didn't get on with it very well. Maybe it's got some more development to do, maybe I just need to learn more how to use it. But it didn't really work so well for me, so I ended up just using volume scatter. And that seemed to do the job I wanted it to do. At the moment, I'm just going to connect that in. There's some more advanced stuff to do shortly, but that has to go to volume, not surface. And let's set the density down quite a bit. We go to Eevee render now and turn this off. You'll see no effect at the moment. If we come up to here and we turn on volumetric, now you can see we are getting an effect. And I can realise that both the lights that I've got in the scene are yellow. So if I come up to here and select my blue light, go to my lamp, change the colour to blue. There you go, you can see it now. Perhaps a little lighter than that. I just put the strength up a little bit. So there's a few things we can do with the settings of volumetrics. We come back up to here, click that little arrow. One of the things you need to do is determine the clipping distance. So I put this up to about 550 meters. You can see that's highlighted it a little more. I also decreased the tile size. This obviously slows the render down. It makes it a higher resolution tile, because Eevee seems to render volumetrics with tiles, which is why it manages to do so quite efficiently. I set that to 4 pixels. Just makes it a higher resolution. I put samples up to 128, and I think I dropped the distribution to 0.7. So that's about the distribution of samples close to the camera. So I actually reduced that slightly. I also turned on volumetric shadows, which will be relevant later, but I left it at the default of 16. Under shadows, which is a little bit lower down, I actually put the cube size up to 1024 and the cascade size to 2048. Essentially all we're really doing there is we're saying store more data, do more calculations to create better quality shadows. In this case, sort of God ray type shadows. I left all the rest at default. So that's our volumetrics. I'm just going to turn the volumetrics off for a moment, and I'm going to come down here and I'm going to make sure I've got my mist object selected and come down here and go to particles. I ended up putting 2 particle systems in. I'll show you why as we go along. So I'll click the plus. So this is my mist, my big cube that I've got selected at the moment. And I click the plus here. Change the name to asteroids. And we'll call it asteroids big. still have to name them twice. Leave it as an emitter. I set the number to 150. Seed, I just randomly changed that. That just means that the distribution will be different to any other system that's created with a different seed. Select frame start to 1 and frame end to 1. But make sure the lifetime is randomly set to a larger number than the number of frames. Source is important. We need to change that to volume. I used random distribution. You can play around with that and see what works for you. Cache, you shouldn't need to change. It should be fine as it is. Velocity, I wanted them to be basically static. So I set the normal velocity to 0 meters per second. Everything else stayed at default. But I switched on rotation. Select orientation axis to none. I left randomness at 0. That would effectively give it a rotation. But I set phase all the way up at tops and phase randomize at top. So that will basically mean I'm given a starting position that is random for the orientation of my object. But I put dynamic on, so that means the object can move. It can have an angular velocity, which brings us on to the next setting down here. So I'm going to change that to random, and I set this to 0.1. So very, very slow angular velocity. So basically each object will have a random angular velocity, a random rotation, but it will be a very slow rotation. If the camera's moving a lot, you don't really even notice it, but it just gives that extra little bit of something to the scene. So physics left at default as Newtonian. I did select multiply mass with size, but I don't think it really makes much difference for this sort of particle system. Under render, we want to render as a collection. And under here, we can select asteroids 001. So that's our asteroids collection there. We can select object rotation. That doesn't matter too much because we're putting a random rotation on it anyway, but we do want to pick the object randomly. And then finally, under field weights, the only one I want to change is gravity, which I want to set to 0. Otherwise, all my objects will just fall out. If we go to wireframe, go back to the beginning, and I'll turn the visibility of my asteroids back on. So you may need to press play to get it to create the particles, but you probably can't quite see them, but there's lots of tiny particles there. These are supposed to be the large ones, so we can come up here and we can play with the scale. Under render, you can see we've got scale of 0.05 and a scale randomness. Let's put the scale up to about 2.5. See, those are much, much bigger now. There they are. And a scale randomness that can be applied now, so they're not all the same size. If we zoom in, you can see they're just randomly rotating very slowly. I only created 3 different rocks. Obviously, you can see the repeated shapes, so you'd probably want to do at least half a dozen. So we'll reduce the scale randomness slightly, but we'll reduce the overall scale to perhaps something more like 2. And then all I did was create a new particle system. We'll call that asteroids small. We'll use the same asteroid big particle system to start with, but then click the 2, and we'll call that asteroids small. I made about 5,000 of these. 5,000. But about 0.15, something like that, for the scale. And as I mentioned before, let's just set the seed to a different random number, and then they won't coincide with the same space. And I'll set the scale randomness right up, which means we'll get really tiny ones. Perhaps we'll increase the scale a little bit for this particular scene. You now can see we've got lots of these really, really tiny ones and a few of the really large ones. If you just create a randomness of 1, you will still get little tiny ones, but they'll be about the same distribution as the really big ones. You won't be able to control separately the fact that you really ought to have a lot of small ones and just a few big ones. So creating more than one particle system is the way to do that. And obviously it doesn't have to be 2, it could be 3 or 4 depending on what you want to control. And maybe the small ones might be more like fragments and therefore not picked from the same set. So we're getting close now. If we just have a look at our rendered version, you can see the lamps are illuminating our rocks. There are no other lights in the scene. And if I also go and turn on the volumetrics, you can see we've got sort of God rays being created too. And isn't it great that that happens so fast, at least in a preview version. And I can even press play, and it's a little slow, partly because I haven't baked anything, but you can see we are getting some effects. These little dots being left, that actually is an artifact of the way that volumetrics is being calculated in preview mode. They aren't there when you do the full up render, but at least it does give you an idea of how things are going to work. And as soon as you press stop, it will create a slightly better version of the render that's much closer to what the final render will be, if not exactly the same. So the only thing we've got left really is the camera motion. And I'll just show you the one thing. The circular orbiting camera motion is just basically put something like a ring, typically a curve, set it to rotating, and then attach the camera to it. There are other ways of doing it, but that's really the easiest way. And how did I get the camera to sort of roughly be following them? Well, actually it's easier than you think. So I'm just going to turn volumetrics off for a little bit, and I'm going to select my camera. I'm going to look through my camera first of all. Now my camera is in this collection here. Just pull it down here so I can see it. And I'll turn my camera on so I can select it. Here's my camera, and obviously we can play with focal length and things like that to zoom in and out. I actually did reduce the focal length a bit, just to sort of make things a bit more interesting. So there is my camera, and I can move my camera in and out and so on, like so. If I press play, you can see there are my objects. I'll back the camera up a little bit more. And if I find that there's a great big asteroid right in the way, well, if I select my mist, which is of course containing the asteroids, go to my particle settings, go to asteroids big, and just choose a different seed. There we go, that's fixed that. But you might want a large asteroid closer, so you can just play around with the seed till you get the sort of effect that you're looking for. It's good to have a good variation of objects. So that's fine, but obviously we haven't got the motion that I had before yet. So let's select my camera again, zoom in a little bit. And now I'm going to go to constraints. So click object constraints here, add an object constraint and make it damped track. Select one of my objects. It can be the lamp or the object itself. I'll go for blue object. And you can see it's moving around, but it's not pointing at the object at the moment. Let's just close this window up as we don't need it now. Move that up a little. It's moving around, but it's not pointing exactly at it right now. Let's select -Z, and there it is. So you can see at the moment, it's pointing precisely at the blue object. Nothing else is holding the camera's attention, as it were. If I turn the influence down, you can see the blue object now seems to move relative to the camera. So the camera is sort of lagging behind it slightly. So if I set that down to roughly 50%, somewhere like that, it's trying to keep the object in sight, but the object's still able to move a little faster than the camera is. But the yellow object is having no influence on the camera right now. By now you may have guessed what I'm going to do. I'm going to add another camera object constraint, which is another damped track. And this time the target is going to be the yellow object. Again, set it to -Z. You see it's now basically just looking at that yellow object, but set this one to 0.5 as well. And now what I'm getting is I'm getting some influence from this modifier and some influence from this one. That means the objects can still go out of the frame, but that both of them are having some influence. Or to be more precise, a point somewhere between the two of them at any given time is roughly where the camera is trying to look, but it's also lagging it slightly. So that just gives you almost someone trying to hold their phone and film these things which are moving around too much. So that's quite fun. If we look here, I haven't got volumetrics switched on at the moment, but you can see that's quite good to see. Baking will reduce some of the lag, but given that this is real time, I think that's pretty good frame rate. So the final thing was just to add a little bit more interest to the volumetrics themselves. So if we come back to here and we turn our volumetrics back on, very homogeneous volumetrics right now, maybe what you want, but let's make it a bit more interesting. So select my mist, and I'm going to add a few more nodes. Let's move that over to here. I'm just going to add the nodes and then talk about what they're doing as I set the settings in them. So first of all, I'm going to add a texture coordinate node. So that's an input node, texture coordinate, and we're going to use the generated output. So this is just to determine the system we use for making points on or within the mist consistent rather than just undefined. So it's the same as UV unwrapping, but we're using generated. I'm now going to add a mapping node. Now my reason for adding a mapping node is because I want to be able to animate what I'm going to do next with the noise. So under vector, we have mapping. I use the generated output of the texture coordinates, and then I'm going to use the mapping output next. So this, if you like, allows me to move around the UV coordinates of my volume. Next, I'm going to add a texture. Once again, I decided to use the Musgrave texture, rather than just defaulting to the noise texture all the time. So I need to use the vector output of my mapping node into the vector input on my Musgrave texture, and I used hybrid multifractal. Again, you can use whatever you want. I used a scale of about 16. Again, the exact scale will vary depending on the scale of your scene, and everything else I left at default. Next, I added my favorite node under converters, which is a color ramp. I took the factor output, so this is basically the same as the color output except it's black and white instead of color, and put that into the input of my color ramp. I dragged the black side up a little bit and the right or white side down somewhere around there, it doesn't matter too much, and I changed it to ease. This is just how the fall off works. Again, these are things I'm not going into too much detail with because you can play around with these to get the effect that you want. Next, I added a converter, which is a math node, changed it to multiply, took the color output from the color ramp into the top input, and then took the output of my multiply node into the density down here. So the reason for that is because this will be too dense otherwise, and having this multiplier node allows me to control the overall density of my fog or mist. So you can see if I turn this down, the mist becomes less dense till I get to 0. So I could go to 0.01, and it's a very low density mist, which may be exactly what you want. I can also come over here and play with the scale. So if I set that up to 24, the variations in my mist become more frequent. They're smaller. I can go higher and higher. If you go too high, it doesn't really work. If you go too low, it doesn't really work either. I think it works somewhere between the two. So perhaps for this particular render, somewhere around there. Now at the moment, that's not animated. The camera is animated, but the mist isn't. If I come out of the camera and just press play, you can see nothing's changing other than the effect of the light on the scene. So we go to the beginning and we hover over the location, and I'm going to press I. I'm also going to hover then over the scale and press I there. Then go to the end of my animation and I change some of these values. So let's go down a little on X and out a little on X and maybe Y and maybe Z. I only changed it a small amount. Press I again and I again. Exactly how much you change it will depend on, in part, on the length of your animation, because obviously whatever change I do here is going to be spread across the animation. Making sure my mapping node is selected, I'm now going to go to the graph editor and I'm going to go to key, interpolation mode, linear. If I don't do that, it will be a very slow change at the beginning, it will be at its fastest during the middle, and it will slow down again as it reaches the end. For this particular type of thing, I would want it to be changing at the same rate regardless. So back to my shader there. If I now press play, you can see, you should be able to see that there is a gradual drift in the noise in this volumetric material, but possibly not enough. So I'll go to the end and I'll perhaps go 0.3 on X, maybe 0.5 on Y, and maybe 0.75 on Z. Store that, and then we'll move X quite a bit more and we'll store that. So now if we go to the beginning and press play, you can see things are changing quite a bit. It doesn't show up so well in the preview. It shows up much better if I just do it one frame at a time. But you can see how the pattern is moving. That's probably even too much now. But that gives you a general idea of how this works. And that's really all there is to creating the animation I did. Did a little bit of post-processing to darken the edges, which I've shown in some of my other tutorials. And I also increased the saturation a little bit, which sort of increased the glowiness of these. You can also turn on bloom, of course, which makes them even more ferocious in their glow, depending on what you're trying to do. I hope you found that interesting. If you did, let me know, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well, and I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.